Hi everyone, welcome back to the video series. In this video we're going to be covering engineering drawings. Those are formal drawings meant for the distribution of your design. It's useful if you're sharing your design with other engineers who are also working on the project, or if you are trying to have the part machined and you're not able to do it for some reason and you need to give the design to a machinist to work on. So let's start with the sidewall. What you're going to do is do design, drawing from design, and you'll have this little prompt. You can change the standard from ISO to ASME, and then we'll keep it on a large sheet size. So I already have one done, but you can just hit OK, and you'll be prompted with this. So we're going to place a base view. That's the primary view. And in this case we want to make it the top view and then change the scale from 1 to 1 so we can use more of the sheet. Okay, and then we're going to create a few projections. This is analogous to if you had a cube and you just wanted to rotate it. So if this is the top, now we're going to see the side and another side, and then we're going to get an orthogonal view. Whoops. And it's typical to make this a shaded view. Okay. What I typically do is the max dimensions. That's what really stands out to me. So let's create a dimension here for 160 millimeters. That's the full length. Okay. Let's also get the width here. It should be 14.6. Let's get the width of this slot and distance between two. We'll get to rearrange these later. We also need the height of the slot from the top, as well as the height of the slot itself. We're going to need the center marks for the circles. So I'm just going to click on any circles or holes, and the fact that we only have one here means that these two have a coincident centers. We also want to do center lines to show symmetry or the center of a hole. So let's go ahead and put one here to note the center of that hole. Put one here. And these holes also correspond to this. And we also want to show that the entire part is symmetrical. So we'll show that here as well as here. And that's a little short, so I'm going to hit escape and extend it up and down. So that's demonstrating that it's symmetric. Cuts down on the amount of dimensions we need to fully define the part. Okay, we also want to show the radius of this as well as the radius of this hole. We want to get the distance from this hole to the top. And we need to make sure that we have the radius of each of these fillets. Okay. That's all the dimensions we should need, but we also need to show the quantity of dimensions. So I'm going to escape again, and we need to show that there are 3 of these boxes. Even though they're symmetrical, they all have the same width. We have 8 of these radii. Oops. We have 2 circles of this diameter. Surrounded by material that radius. We also need to show that the three of these are each 6.6 millimeters high. And I'm going to move this so it's a little nicer, as well as this. Okay. One very important thing that we need to have as well is the units. So I'm going to go ahead and add some text here. That all the units are in millimeters. Okay. Now you can just save this and export it as a PDF. That's one of your files. Let's also do the motor mount, because although we'd like to have it 3D printed, you may need to get it manufactured some other way if you're using a different material. So again, we're going to hit Design, Drawing, from Design, change the standard to ASME, and we'll keep it on a large sheet. And it's a B paper. Hit OK. I'm going to go over to my started drawing. Okay. Let's place our base view again. In this case, I'm going to change it to 2:1. Since our paper is so big, we can use the extra space. And this front view is good as a base view because we can put a lot of dimensions on here. Let's give the projected views to the top as well as the side, and the orthogonal. Change that to shaded. And if you need to change the orientation of your drawing, if when you made it, you started it on a different plane, whenever you're placing your base view, you can just change the orientation here. Or if you've already placed it, you can just edit the view. Okay. So again, I'm going to start with the major dimensions. It's 44 millimeters wide. 24 millimeters deep. This cutout is 10 millimeters. Let's go ahead and mark the holes. Okay. There's center lines here and here, as well as here and here. In this part, you see a lot of these dashed lines. Those are hidden lines. So they're lines that you can't see on the part. So you see these two. These denote the edges of the hole, which you can't see from the front, which is what this view is. But it shows that they do exist within the part. And they're nice references for when we're making center lines, for example. We also want to have a center line for the whole part here because it is symmetrical left to right. And again, I'm going to go ahead and extend that to show that it's symmetrical from top to bottom. And we're going to put the corresponding center mark here. And again, I will extend that. Okay. Now, we also want to show the radius of these holes. Put that here. The radius of these fillets. Zoom in if you have to. We also need to show how far the holes are from the edge. You can use the center mark as a reference point, and here as well. Okay, and let's show the radius of the outer part of the material, the inner part of the material, as well as this small fillet. Go ahead and show the height of the flange, and let's also put a center mark for the motor slot. Okay. let's define a bit more about this. So 7.7 millimeters tall. And then also using the center mark, it is 10 millimeters from the base and 2.3 millimeters from the bottom. Okay. Let's show that this is 2.8 millimeters from the center of this. That's about everything. Let's make sure we number certain units here, certain dimensions. So we have 4 of these holes of this diameter with 4 outer fillets, which are 4 times this spacing from the edges. Okay, we only have one of these circles, only one of these not circles but arcs. We have 2 of these fillets, and we want to show that this occurs twice. Sometimes you have to do this when you can't use a center line because that part is not symmetrical in that way. Okay, and let's go ahead and once again say that all the units are in millimeters. It's not always included in the drawing template. For example, in this ASME template, it is not included. It's always important to show what it is. All right, and once again, you can save it and export it as a PDF, and that'll be another one of your files for submission.